Hello everyone, welcome to the video, and in this video we are going to see how we can perform clustering algorithm within Power BI. Yes, you heard it right. You don't need Python or any advanced machine learning knowledge. You can directly perform clustering within Power BI, and in this video we are going to see how you can do that. In this particular scenario, let's say we have given a data set, right? And we have to group them somehow, but there is no fixed criteria for grouping it. So for example, as you can see in front of you, you have a data set, right? This is basically a iris flower data set, and these are the various species of iris, right? So it's called as setosa, versicolor, and virginica, right? And these particular species, right, have some features, like have some particular sepal length, sepal width, petal width, etc. And accordingly they are classified as which species they belong to, right? But what if you have not given this species column at all, right? You have just given some numbers, and you have to group them together. You have to group them somehow. You need to create clusters. How can you do that? There is no fixed criteria, right? You need some kind of machine learning technology to do those things. Now where it would be useful, so for example, you have some email data, right? Or maybe some customer data where you need to cluster your customers based on various pattern. Maybe it's their behavior of visiting your website, visiting your mobile apps, or something like that. But you don't have a particular cluster of your customers. How you can do that? Within Power BI you can actually perform those kind of clustering, complex clustering, where you have multiple data and there is no set rule on how you should divide the things, right? So we are going to do exactly the same thing, okay? And we are going to do this in this particular data set, right? So you can say, okay, we have the species, right? So what we should cluster? So yes, we have the species, so that we can validate how good is our clustering, right? But we will not take this species into account. We will just use the species as our final validation, right? So how good our clustering is. So for that we are going to use this species thing. Okay, so I will do it from entirely from the scratch. So what I'll do is I will search here for the iris dataset, right? And definitely for the iris dataset you can get various links. It's a very popular dataset, but let's go to this particular gist, right? So this is a GitHub gist. Someone has pasted this dataset here. So let me just go here, and here we have this dataset, right? So I'll click on this raw link. So here I can just paste that particular link. You can see that at the end we have iris.csv. So I will click on OK. So it should load the data. So now you can see we have given a preview of the data, and let me click on OK. And this is the data that we have, right? So let me just name it something better. So iris main, something like that, right? And you can see we have this much data, right? We don't have any primary key here, okay? And I think we need that, but when we are going to need that, I will tell you when we research more into it, right? So I will just click on close and apply. The data is now loaded, and we can see that we have our table here. Okay, now let's try to create a table visualization, right, where we will post all our basically all the columns that we have. Okay, now you see the problem. We have so many rows of data, right? We have so many rows of data, but what it does, it actually summed all the sepal length, sepal width, petal length, petal width, and just give us the three colors, because there was no identifier column or unique identifier column for each row. Okay, obviously we can remove this particular, right? We can remove this, make it don't summarize, so that we get entire rows of data, but still we are missing an index column here. Okay, so now you see we have this full data set, right? And then if I click here, you can see that there is an option called as automatically find clusters, right? So let me click that. Okay, so once I click that, it is giving me an error. It is saying that clustering supports one dimension and 1 to 15 measures, right? So you can provide multiple measures, but you cannot have so many fields, right? That is the issue happening. But we want to find clusters, right? So what we should do? So one way is to we will create the measures. Instead of having these columns, we will create four measures, and these are very simplistic measures. If you see, I have already created these measures actually. You see, this is for petal length and simply sum of petal length, and this is for petal width, simply sum of petal width, then sepal length, simply sum of sepal length, and then sepal width, simply sum of sepal width. Okay, let's delete this particular table. Okay, now what I'll do is I will create another table. Okay, we'll take same thing, but here we will take the species and then all these measures, right? But again, you see that problem because the measures needs to have some aggregation like sum, right? So we are getting some of those things. So here if I put some cluster, that actually doesn't have any meaning to it. Okay, because there is no meaning of grouping this three rows and sum up sepal width, or even if you take average, it doesn't have any sense. Okay, we should do is we need to have a identifier column here. Okay, so we can add a identifier column using in Power Query. Okay, it's very easy. So all we have to do is here, if you come and then if you go to add column, then you have this option called as index column, right? So if you click here from one, it will create an index column, which you can see I already have it here, index column. So now if you see this data set and this data set, these are two identical data set now. Okay, so once we have this, right, I can basically close and apply. Now you see, now I can add index column here as well. So once I add index column, now I'm getting every row, right? So each row, because now I have a unique identifier for each row. Okay, so now I can remove the species not required because now we want to group, right? Now you see these are all four measures and this is just one column, right? One column. So now if I click on automatically find clusters, it will find clusters. Okay, so here my cluster name is, let me name it as species. It's not actually species, it doesn't have any idea about species, it is just clustering using an algorithm known as K-means clustering, right? So species cluster, something like that, cluster of index, and how many cluster we want, right? We can increase it. It will first of all try to automatically find clusters, maybe two clusters or three clusters, but we can also provide some numbers. Like let's say if I want three clusters, I can provide three and click on OK, right? So now it will create a cluster using a clustering algorithm, right? And you see it is automatically added here. So it created cluster 1, cluster 2, cluster 3, and you can see the same thing here. I already prepared it, and you can see we have clusters, and I also added this species column here. So you see cluster 3 is Setosa, but here also cluster 2 also Setosa. So you see there are some kind of errors there, but yeah, that is obvious because it doesn't have any idea on how to group the things, but it does some fair job actually. So if I'll go to this page 1, okay, so here I have created some scatter plot. Now in this scatter plot I have sepal length, sepal width, but here I have colored it based on the various species, right? So this one is Zetosa, this one versicolor, and this color is Virginica. And now here I have provided those clusters that we created. Now if you see, right, if you see, it is clustering this one as a one cluster and these two as two separate clusters. Okay, so for Setosa it is actually dividing the Setosa into two clusters. Okay, and versicolor and Virginica, it is getting uh, basically making the Virginica and vesicular as a same cluster. It is thinking, and here also you see vesicular and Virginica are like two clusters here, but here if you see our clustering algorithm considered them as mostly one cluster, and something here and something here. Okay, so there are some kind of error, but you can see In real problems you will not have this categorization like we have here setosa, virginica, versicolor, and then we that's why we are side by side comparing our clustering algorithm result with the flower species result, right? But in real scenarios you won't even have this categorization. Now whatever you have at the end of the day, that is the ground truth for you, because for clustering algorithm there is actually nothing for you to compare. Okay, so if it has been a real use case, the data set that you will be having is just these 4 columns, that's it. And then you need to find out clusters. But I think you got a fair good idea on how to cluster your data set in case if there is a need for clustering. Let's say maybe you are doing some customer segmentation problem or market segmentation problem, something like that, and you don't have a particular uh, clustering for your customers or for the different markets that you have. So you can use this technique within Power BI. You don't have to know Python and all these algorithms, right? So I hope you learned a lot from this video, and I will see you next time.